Okay, so welcome back to part 2 of our discussion of antiderivatives. So remember, an antiderivative capital F of x for some function little f of x is such that f prime of x is equal to little f of x. So basically, a way of thinking about it is, as the word suggests, antiderivatives and derivatives in some sense cancel each other out. And last time we did talk about a couple examples, so let's do a couple more. So one of the simpler ones that started off with was sort of power rule type things. So if I want the most general antiderivative, I first add 1 to the power, and then divide by the new power, and add plus c. Or, this is x cubed plus c. And that's how these ones work. And another example. X to the pi. If we want to find the antiderivative, this is again power rule, so you add 1 first, and then you divide by the new power, and then you plus c. Okay, so let's do an example with some trig in there. Alpha x equals secant x tangent x minus 2e to the x. Well, my thought process here is, what, when I take its derivative, gives me secant tangent? And well, that's secant. And then minus 2, antiderivative of e to the x is always just e to the x. And I'm just getting that from, just remember, derivative of e to the x is e to the x, so it stays, and constants always pull through. Okay, so that's it for a couple examples. There's one little thing at the tail end of this section. Up to this point, let's say we have the derivative being 2x, then our antiderivative would give us x squared plus c. Well, what's really common in word problems, in what we're going to call rectilinear motion, is they'll say, let's have these two conditions where I'm not only given the function, but I'm given, say, f of 0 equals 5. Then what I could do is I can actually find what is that c value. So it's f of 0, which is 5, is 0 squared plus c. That is, c is 5. So now I can actually give you, what is this function? Well, it's x squared plus 5. These sort of things are often called initial conditions that they're giving. And they show up a lot in different fields, not just in physics with motion. So let's do an example to just show. Let's say f of t is 2t plus 1. And we have the conditions f of 0 is 3, and f prime of 0 is 2. and it says find f of t. Well, we take the first antiderivative. That will just give us f prime. We have to take antiderivative of each term. So the antiderivative is going to be 2t, add 1 to the power, divide by new power, plus 1 times t, or, well, plus c, or t squared plus t plus c. So then we can use the condition that f prime of 0 is 2 to give us 0 squared plus 0 plus c equals 2. That is, c equals 2. So our derivative that we have here now is t squared plus t plus 2. So let's clear some space. So we know it's t squared plus t plus 2. And we can find, well, what's the antiderivative of that thing? Well, that's going to be t cubed over 3 plus t squared over 2 plus 2t. That's just using the power rule for antiderivatives, plus c. But we still have this condition. So f of 0, which is 3, gives us 0 plus 0 plus 0 plus c. So our c is 3, giving us what the function was. It was 1/3 t cubed plus 1/2 t squared plus 2t plus 3. So this idea of rectilinear motion is just applying it to this new situation. So along those lines, you could have word problems that will look something like what I'm about to give you. So a stone is dropped from the upper observation deck of the CN Tower in Toronto. "450 meters above ground. Find the distance at time t." Well, we're talking about in terms of meters, so one little fact about physics I'll say is you have negative 9.8 is your acceleration. So that's the second derivative of distance. What else do you have? Well, it's being dropped, so you're not throwing it towards the ground, you're just dropping it. So its velocity at time 0 is 0. And its position, I'll put it as s, is its distance at time 0 is, well, it's 450 meters above the ground, so we'll say that's 450. So, can we take our s double prime equal a equals 9.8 and take this information we have and find what our function s is? Well, yeah, if we take the antiderivative of s double prime, we get negative 9.8 t plus c. But that's just velocity. And v of 0 equals 0 plus c. So c And with that being 0, that means c is 0. Okay, so that means our velocity is negative 9.8 t. Let's take the antiderivative again to give us s, because velocity is s prime. That's going to give us negative 9.8 t squared over 2 plus c, or negative 4.9 t squared plus c. And now we have this last condition, that it's 450 at time of 0. So we can just plug in 0 for that t squared. We'll get 0 plus c. So c is 450, giving us the final equation that our function that tells us what distance you are at time t is negative 4.9 t squared plus 450. So these problems are straightforward, they just take applying this idea of antiderivative. So if you have any questions, don't forget you can comment on this video, and you can also message me on Canvas. I will see you all virtually.